Hi, good morning or afternoon. All right, so I have some notes today for solving quadratics. We're going to look at two different approaches to solving. We're going to look at factoring, which we have been doing, and then also taking square roots, which is something new, but something that you've done before. When we're solving by factoring, it's important to take into account the zero product property. So the zero property says that if A times B equals 0, multiplying two things, their product is 0, then either A is 0, or B is 0, or both A and B are 0. So for our factoring problems, we're going to take the assumption that A and B are both 0, and then help us find values. So in order to solve by factoring, we have to factor first, but you do need your equations set equal to 0. So before we just had these expressions where there wasn't anything on the other side of the equal sign. So now we have an equal sign and it has to be equal to 0 because I'm going to use the zero product property and I need it to be 0. So I'm going to factor this quadratic into two factors. I'm going to do this problem using the product sum chart. So my product needs to be A times C. My A value is 1, my C value is 36. So that will be 36 for product. My sum will always be my B value, which is a positive 13. So I'm looking to multiply together to give me 36, add together to give me 13. I'm going to write them out. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So there is one product that has a sum of 13. So I'm going to take my 4 and my 9 and divide them by my leading coefficient, which is 1. They don't simplify, so I'm going to go ahead and put them in as factors. So I have 1x plus 4. I left the 1 off. And then I have 1x plus 9. I left the 1 off again. So I rewrote the left-hand side of my equation as the product of two factors instead of a written out quadratic. The right-hand side will stay the same, which is 0. So I have factored. Now I need to solve. So when I solve, I take it one step after factoring and I take the two factors. These are my two factors and I set them each equal to 0. So essentially when I'm looking at like A times B, this whole thing is the A, this whole thing is the B. So I take the two factors separately and set each one equal to 0. And then I solve them. So for this first one, I'm going to subtract 4 from both sides. So x is going to be equal to negative 4. There is one of my solutions. And then for this one, I'm going to subtract 9 from both sides. So x is equal to negative 9. That is my other solution. In dealing with quadratics, just a small hint, like x is squared, I'm going to end up with 2 answers. And here are my 2 answers. Now, if I want to double check, the nice thing about algebra, you can always check your answers. So to check it, I'm going to use my handy-dandy calculator. And I'm going to plug in negative 4. Be careful of your parentheses because I want to square the whole negative 4. Just keep my parentheses with my x's plus 36. So this should give me 0. And it does. Then I can do the same thing with my other solution, negative 9. And it will also give me 0. So just a good way to kind of double check, make sure you get it correct. All right, so for my second example, I'm going to use the grouping method. I like to group it. You like to? Okay. So the first thing I need to do here, I need it to be equal to 0. And right now, is that equal to 0? There's a negative 35 over here. So I'm going to move this 35 over. So I have 0 on one side of my equation. This 35 doesn't combine with the 2x squared. It doesn't combine with the 17x. It's its own term, so I'm just going to stick it at the end. So I have 2x squared plus 17x plus 35 equals 0. So I'm looking for a product of 2 times 35, which is 70. And I'm looking for a sum of that B term, which is 17. So multiply together to get 70. I can do a little bit right out here. 4 won't go in. Or 3 won't go in, 4 won't go in, 5 will go in. Ooh, this is a little embarrassing. 70 divided by 5. Ooh, it's 14. So that's 19. 6 doesn't go in, 7 does go in, and that will give me my 17. So I'm going to rewrite my 17x as 7x plus 10x. now will equal 0. I'm going to group them together, my first two in a group, my last two in a group. Take out my greatest common factor. So from this first set, I can take out an x. Then I'm left with 2x plus 7. In the second group, I have 10x and 35, so I can take out 5, and then I'm left with 2x plus 7. So then my two factors will be the coefficients, x plus 5 as a factor, and then the 2x plus 7. So I have factored. So sometimes we get confused as to, like, when do I stop with the factoring, when do I stop with the solving? So you factor when you have the product of at least two things equal to 0. Then I have to go through and solve. So I'm going to set these two factors equal to 0. So I have x plus 5 equals 0 and 2x plus 7 equals 0. And I'm going to solve them each individually. So I'm going to subtract 5 from both sides here. So we're in a little bit out of room. So I have x equals negative 5. There's one of my solutions. And then for this one, I'm going to subtract 7 from both sides. So I'll have 2x equals negative 7. Divide by 2. And I'll say that x is equal to negative 7 halves. I like fractions, especially if they are nice and reduced. You can do them as decimals as long as your decimal is terminating. So I would be fine with a negative 3.5, so whatever works for you. I can plug these back into my original and see if they work. All right. So the other way that we're going to solve is also by taking square roots. So by taking square roots, you isolate the squared value, whatever's being squared, and then you square root both sides. You got to watch out for your positive and negative on the square roots, because if I were to square root something, it could be a positive or negative. So we'll see that in our first example. So I want to simplify or solve x squared is equal to 25. So I have isolated my squared value, which is x. So I'm going to go ahead and square root both sides. So the square root of x squared, like these just cancel each other, and that's just x. 25 is a perfect square. The square root of 25 is 5. Another square root of 25 is negative 5. So I don't know if you remember back in the day when we took square roots, sometimes we put a plus minus in front. I am okay with a plus minus as long as it's a positive and negative of the same integer value. If I had a positive 3 and a negative 4, then you don't need a plus minus. But if it's the actual same value, then it will work. So square roots, I literally just square root it and then simplify. All right, I got a couple more examples of solving with square roots. So with number 4, I'm going to solve with square roots. But before I can square root both sides, I have to get rid of what's not being squared. So in this problem, only the x is being squared. Only the x is being squared. This 3 is not squared. If 3 were squared, along with the x, it would look like this. Right? So only the x is being squared. So this 3's got to go. I'm going to divide both sides by 3. So I'll have x squared is equal to 36 divided by 3, which is 12. Now I've isolated my squared term. I can square root both sides. So the square root of x is x. And this is equal to, I'm going to go ahead and put a plus minus here, the square root of 12. Now, 12 is not a perfect square, but I can break it down. I'm going to do 6 times 2, and then 2 times 3. So looking at my prime factorization, I have a 2 on the outside of my radical, a square root of 3 underneath my radical. I can either write that as the plus minus, or I can write them out as a positive 2 times the square root of 3, and then a negative 2 times the square root of 3. This usually just saves us a little bit of time. This is being thorough, seeing them. I'm good with either one. For my last example, I'm not going to be able to use the plus minus. I'll show you why in a minute. So I have 1/2, and then I have x minus 6, which is being squared, and then a plus 6, and then a minus 36. These 6's don't cancel out, because this is being raised to the second power. This is my squared value. This is what's being squared. So this is what I need to isolate. So the 6 needs to go, and the 1/2 needs to go. So I'm going to move the 6 first by subtracting. So 1/2 times the x minus 6 squared is going to be equal to 30. Then I need to get rid of this 1/2. I'm going to multiply by its reciprocal. The nice thing about fractions, you can multiply by their reciprocals, and then that just gives you a multiplier of 1, which is kind of invisible. So I have x minus 6, which is squared, and that's going to be equal to 30 times 2 over 1, which will be 60. I want to point out that when I square root this, the square root completely goes away, and I just have the x minus 6. It's kind of fancy. So x minus 6 will be on the left, and then I'm going to put a plus minus here, the square root of 60. So I'm going to look at 60, see if I can break it down. It's not a perfect square. Let's see, I can do 2 times 30, and 2 times 15, and 3 times 5. So I can do plus or minus 2 times the square root. So I'm going to put a 2 on the outside, and these have to stay. 15. I'm not done. I haven't solved for x, but this 6 needs to move to the other side. So I'm going to add 6 to both sides. I cannot add 6 to a square rooted coefficient number, so I'm just going to stick it at the end. So x is equal to plus or minus 2 times the square root of 15, and then a plus 6. So there's my two answers combined together. Or I can do 2 root 15 plus 6, and I can do a negative 2 root 15 plus 6. So the one that has the positive and the negative is the number that came specifically from my radical sign, and then the 6, like I have to add it to the other side, so the 6 always stays positive. One thing I want to show you, if you have a problem, let's say that I had x minus 6 and that was squared, is equal to 100. And I square root both sides. 100 is a perfect square. So x minus 6 is equal to, when I square root it, plus or minus 10. When I move the 6 to the other side, I can actually add the 6 to the 10 and the negative 10. So if you're simplifying with radicals and it comes out to be a perfect number, please don't use the plus minus. Please break this down into positive 10 plus 6 and negative 10 plus 6 to get your two answers. Again, if you have a whole number that comes out of the radical, don't leave it as a plus minus. Do one with the plus, one with the minus. So here x is 16, and then here x is negative 4 in solving the problem. So this is just an extra little half example. Watch out for those perfect squares. I cannot remember if I gave you the homework, so I will have it posted into Canvas for you to work on, and then we will collect them. I don't remember. We'll figure it out. Let me know if you have questions.